In the first part of homework 9 here, we've got a table that gives us information about 5 different substances. We've got melting point, boiling point, solubility in water, and conductivity of solution. Now the homework is about properties of different types of substance. So we need to remember the different types of substance first, different types of bondings. The first type of bonding is ionic. Now, ionic bonds are made between a metal and a non-metal. The metal gives its outer electrons to the non-metal. We end up with charged ions. The metal is positive, the non-metal is negative. The charged ions attract each other, so the melting points are going to be higher. So anything with a low melting point here, therefore, hexane and octane is not going to be ionic because these are too low. So we've got 3 that may be ionic. Okay. So the first thing we're looking for is, are they made of a metal and a non-metal? Remember, the periodic table gives us information about whether things are metals or non-metals, and the periodic table is just here. So the metals are on the left of this line and the non-metals are on the right of this line. Okay, so we need to have a good look through find out where copper is, where sulfur is, that's sort of the sulphate iron, sulfur and oxygen. We need to have a good look for where silicon is and where oxygen is. We need to have a good look about where sodium is and where chlorine is. Now, so long as one of them is on one side of this line and the other is on the other side of this line, they're probably ionic. Okay, if they're both on this side of this line, then they're not ionic. They will be covalent. Now, covalent bonds are formed when 2 or more non-metals shares pairs of electrons. Now, there's 2 types of covalent substance. There's simple molecular and giant molecular. Now, simple molecules have low melting points. They have low melting points because although the covalent bond is strong, the covalent bonds within a simple molecule stay within that molecule. So one molecule is not attracted to another. For example, here is, say, a water molecule there, and here's another water molecule here. The bonds within the molecule are strong, but there is nothing between the molecules. These are weak forces of attraction between the molecules. So they don't take a lot of energy to separate one water molecule from another water molecule. Therefore, we would expect simple molecules with low melting points, simple molecules to have low melting points. So quite possibly hexane and octane are simple molecular here, but you can make that a final decision. The other type of molecule is a giant molecule. Now, in a giant molecule, the non-metals bond to every other non-metal with a covalent bond, and those covalent bonds run throughout the entire structure. Now, those covalent bonds are incredibly strong. So giant molecules have extremely high melting points and boiling points, very high melting points and boiling points, because to melt them, you have to break all those strong covalent bonds. Right, solubility in water. Now, as we've seen before with ionic substances, some are soluble and some are insoluble. And that's the same for simple molecules, to be honest. Some are oil. Oil does not dissolve in water. Oil is simple molecular, but then other simple molecules, like chlorine, for example, Cl2, the Cl2 molecule, that will dissolve in water. So some simple molecules are, some simple molecules are not soluble. So essentially what I'm trying to say to you is the solubility in water doesn't help us overly, if I'm honest. Giant molecules are insoluble. We can say that for an absolute fact. Giant molecules are insoluble. Conductivity of solution. Now, this does help us. Ionic substances, when they're in solution, if they do dissolve, when they're in solution, will definitely conduct electricity. Okay, so that one does help us with to identify an ionic solution. So, in this table here, the first thing you have to do is state, and that table goes to the next page as well, here, you need to state whether they are, what type of bonding is present. This first box here, which of the compounds in the table are liquids at room temperature? So you need to look at the melting point and the boiling point and make a decision there. In the past, I've suggested you use a sort of number line to help you. So what we've got is we're going to have the solids here, and then liquids here, and then gases here on this temperature number line. Okay, solids, liquids, and gases. And what we're then going to plot our melting point and our boiling point on it. So let's do hexane. I'll do hexane for you, you can do the rest. So the solid turns to a liquid at the melting point, and that happens to be with hexane minus 95, minus 95. So anything colder than minus 95, it's a solid. So minus 100, minus 105, minus 110, minus 115. As we go down here, down this number line, that minus number is going to get ever bigger. So anything temperature beneath minus 95 is going to be a solid. It boils at 69, so let's put 69 there, 69 there. So anything above 69 is going to be a gas, so 70, 75, 80, 85, always a gas. And anything between these two numbers, it's going to be a liquid. Now, the question here says at 25 degrees C, which are liquids? So we need to put 25 on this number line. Where's 25 going to appear? It's not going to appear here because this is any number greater than minus 95. It's not going to appear in the gas bit because that's going to be any number over 69. So 25 is between these two numbers. So 25 is about there. So 25 for hexane is indeed a liquid. Liquid hexane. So we can definitely write hexane in that. Are there any others? So you can put a number line together if that helps you. Next question. Why does silicon 4 oxide have such a high melting point? Well, listen to the introduction I've just given you. Okay. Decide what type of bonding is present in silicon oxide and then explain why it has a high melting point. I'll tell you, it's, you know, if this question said, why does so-and-so have a low melting point, and that so-and-so was a simple molecule, would say because the molecules aren't attracted to each other, they're easily separated. Okay, that's not the case in silicon 4 oxide. So what type of bonding is it? And then explain why it has a high melting point. Why does octane have a low melting point? Well, I've possibly just given you a hint with the previous one there. Okay, again, look at the type of bonding present in octane. So what answer did we put here? Okay, and then say why the melting point is low. Why does copper sulphate solution conduct electricity? Again, we have to look at what type of bonding is present. Once we know what type of bonding is present, we can explain why it conducts electricity. Remember, if it's going to conduct electricity, okay, you have to understand what a current of electricity is. A current of electricity, okay, is a flow of charged particles. Now those charged particles are either electrons or ions. An ion is a charged atom. So why does copper sulphate solution means liquid, conduct electricity? So you have to decide whether there are free electrons or whether there are ions that can move. So have a look at the type of bonding and decide whether there are free electrons or ions that can move when copper sulphate is a liquid, and then explain it there. Octane is also known as petrol and is burnt in car engines. Write a balanced symbol equation for the complete combustion of octane. Well, I'm not going to do octane, I'm going to do pentane. I'll do pentane for you. So pentane is also a hydrocarbon. It has the formula C5H12. That can burn. When it burns, it reacts with oxygen in the atmosphere. The atmosphere is air. It's 21% oxygen and 78% nitrogen. And when things burn, they react with the oxygen in the atmosphere. And that oxygen is going to oxidize its hydrocarbons. The carbon is going to oxidize to make carbon dioxide, and the hydrogen is going to oxidize to make hydrogen oxide, otherwise known as water. Okay, so you'll get 2 marks for writing the formulae of the reactants, 1 mark, and the formulae of the products, 2 marks. So that gets us 2 out of 3 marks. Next is balance it. So start with the carbon maybe. There's 5 carbons on the left, so we need 5 carbons on the right. Let's put 5 before the carbon. There's 12 hydrogens there. Well, there's 2 there. So what number times 2 makes 12? Answer 6. 6 times 2 makes 12. Put a big 6 in. Now count the oxygens. 5 times 2 is 10. There's 10 oxygens there. And the 6 times 01, there's no number after the O, so there's a 1. So 6 times 1 is 6. So 5 times 2 is 10. 10 plus 6 is 16. There's a 2 there. So what number times 2 is 16? Answer 8. 8 times 2 is 16. So that's pentane. balanced, C5H12, you have to do octane. Okay, it's similar but different, so that's not the answer, but it should hopefully help you. Our last question with this homework is to complete this table. So we've got either an atom or an ion in this column here, and I simply wanted information about that atom or ion filled in. So I'm not going to do any of these for you. I'll do, say, what did I do? Potassium. Okay, I'll do potassium K. Okay, so to find the information to start with, you need a periodic table. So we need to find potassium on the periodic table. Potassium is here in group 1. And we've got two numbers next to it, 39 and 19. Okay, 39 is the mass number and 19 is the atomic number. So you find your periodic table. And then you can fill those in, 39 and 19. You're not expected to learn these. You're given a periodic table, you just need to be able to find them. Now, the atomic number is sometimes known as the proton number. Okay, so that is sometimes called the proton number. And if you can't remember that, it's a really handy with the Excel, is a key here on the periodic table, and it tells you beneath the name is the atomic or the proton number. So that tells you that's the proton number. So there's 19 protons. There's going to be 19 protons. Now, the number of protons for an sorry, I've written that in oxygen, haven't I? The oxide ion. That's there for the potassium. 19. The number of protons never changes. So atoms cannot lose or gain protons. Now, neutrons. Neutrons have a mass of 1. Okay, neutrons have a mass of 1. And so do protons, whereas electrons have a mass of 1 over 1846. Okay, so electrons are virtually weightless. So the mass number here is going to be made only of protons and neutrons. So it's going to be the mass number is equivalent to the total number of protons and neutrons combined. So if there's 39 protons in total, 39 protons and neutrons in total, and there's 19 protons. The difference, in this case 20, because 20 and 19, total 39, the difference must be the number of neutrons. Now in elements, the number of protons, positive charges, equals the number of electrons, because elements are electrically neutral. So if there's 19 protons, and protons are positively charged, neutrons are no charge, electrons are negative, there must be 19 electrons. And that's for atoms. Now, what if we were doing the potassium ion? Well, the mass number is still 39 because the nucleus is unchanged. The atomic number is still 19 because the nucleus is unchanged. The nucleus never changes. If the nucleus is unchanged, the number of protons must be 19 and the number of neutrons must be 20. The nucleus never changes in chemical reactions. What can change, though, are the number of electrons. So if it's positively charged, okay, has it gained or lost electrons? Well, I could write out all 19 protons here, but let's just imagine I was doing lithium for a second, the lithium ion. Okay, the lithium ion has an atomic number of 3. Okay, that means it's got 3 protons. 1, 2, 3. So when it's an element, it has 3 electrons. Okay, because the protons balance the electrons when they are atoms of elements. Now, when the lithium forms an ion, okay, it becomes the lithium positive ion. So, did it gain or lose electrons to become that? Well, think about it. If we scrub that electron off there, that proton is balanced by that electron, that proton is balanced by that electron, that proton is now all on its own, which is that positive charge. So the lithium atom became the lithium ion by losing electrons, and it's the same here with potassium. The potassium atom became the potassium ion by losing an electron, so that would be 18. So when it's an ion, long and the short of it, when it's an ion, it's either everything else is the same, is either gained or lost electrons. If it's positive, it's lost. If it's negative, it's gained. And that should help you fill in that table.